Alright, hello and welcome to the build video of the MiniacRC Mighty Mini B25 Mitchell. This is a FliteTest style plane built out of 2 sheets of Dollar Tree foam board and 1 sheet of 11 by 14 poster board, all from Dollar Tree. So the whole airframe is just about $3 to $4. This runs off of the Mini Twin 8-pack provided by FliteTest, but if you can't get that, any 1806 motors powered by 3-cell, around 2280 to 2300 kV, running 6-inch props should make this ship fly really well. Be warned that this is a rather difficult build, and it is a strong intermediate plane to fly, so I highly suggest that you build and fly some other FliteTest models before you come to this one. If you're looking specifically for a twin-engine trainer, I highly recommend the Mini Guinea, which is a wonderful twin-engine cargo plane by FliteTest, designed by Peter Schriepel. The Mini 8-pack will give you pretty much everything you need to build this plane other than your battery, your receiver, your transmitter, and a Y harness. The Y harness is important for these twin-engine planes because it allows you to power 2 motors off of 1 battery voltage. All the specs for this build are provided on the plans on the front page, so I highly recommend that you check that out. Go ahead and gather all your parts based off of the list that's provided in the release article for this plane, and you can find the link to the article below this video. Go ahead, get all your materials in order, and let's begin. Okay, so we're going to start off with our vertical stabilizers. Go ahead and remove the 2 tabs that you see. We're only going to remove the paper and the foam from the top, and we're not going to cut through the entire thing. So this one was a little bit shabby, but as you'll see, the deeper you do your initial score cuts, the easier the tab will come out, and if you're really lucky, you can get it down in one piece. So we're going to set those aside and move on to the horizontal stabilizer. Go ahead and break open your elevator score cuts, and also remove the 2 tabs that you see. Once again, you're only removing the paper and the foam to make it a cavity rather than a full cut. And that's mainly just for looks, so that you don't see the cut through the top. These are some of the skills that make this build a little bit more difficult. So now go ahead and make your bevel cuts on the elevator. And always, if you don't like what comes out on the first try, we're not all Josh Bixler, you can go back with a sanding block and clean off the joint to make it more even. Make sure you have good deflection on both elevators. But now we have to bind together the motion of both elevators so that they move together. And for that, we're going to use a custom U-shaped torque rod. Now you can see the diagram provided on the plans, but you don't have to follow that exactly. This is a custom step. So one of the cuts is already provided for you on the plans for the elevator. So make your U-shape and press one end of the torque rod into that score cut. I'm having to do the initial cut myself because this is a previous version of the plans, but you should already have that established. Go ahead and press it in, and this is the custom part. Wherever it falls on the other side, wherever it falls down, make another score cut for the torque rod to sit down. Open up the score cut and make sure that your torque rod sits down in a good dry fit. So now go ahead and add glue on only one side at a time. Press in one leg of the torque rod and remove all the excess. This is a really important step because this is essentially going to be controlling the most important surface on your aircraft, which is the elevator, especially for this B25. Now go ahead and lay it down on the other side. And this time you can't use your fingers to press it in because you have hot glue over there, so you might need to use something sharper like a blade or a push rod. So now you should have even motion, and make sure that the torque rod itself doesn't interfere with the motion of the elevator. So press it in as deeply as possible, and you should have a good healthy plus or minus 20 degrees to work with. Okay, so let's get started on the wing. Grab your 6 pieces and let's get started. Again, we're going to start by removing these 4 slots that you can see. This is where the spars will tab in. And again, we don't want to be seeing those tabs on the bottom surface of the wing when we fly, so this is just an aesthetic matter. So now we're going to go ahead and remove these pieces that you can see, because this is where the wires from the nacelles will pass through. But go ahead and save these pieces for later, because they're going to come in useful later on. So now go ahead and open up your score cuts for the fold over on the wing. You're going to have a total of 8 score cuts to do, including this centerpiece. And also, make sure you score cut the dihedral score lines. That's going to help you establish the shape of the wing. Go ahead and fold over the wing and do your bevel cuts on the leading edge so that you establish a double bevel. This is the same process that you would have used on any of these FliteTest wings. Again, if you don't like what happens the first time, you can go back with a sanding block. I prefer the Dollar Tree sanding block. It's just $1, and I've been using it for like a year, and it's in the same condition that it started, so it's a great option. So once that's done, go ahead and start establishing the fold over for the centerpiece and the left and the right pieces. Don't force this the first time. Make sure you take it in stages, one step at a time. Go ahead and fold it over a bit, then open it up, and then fold it over again so that you don't break anything off. Once you do that, you'll see that you're already establishing some of that dihedral. Now go ahead and make sure that you have a textbook or the edge of a table to work off of so that the process is easier. The back spar is actually going to have a tab on it that sticks out, so that's how you differentiate it from the front spar. Make sure the score cuts are facing the front of the wing, and go ahead and lay only one side of the spar down at a time, because I'm going to be saying this a lot, but this wing has a dihedral, so it's not going to lay flat on the table. So if you try to press down on both sides of the wing at the same time, you may crack it open, and that's not a good thing. You want to establish that dihedral on the centerpiece. So glue in one side of the spar, and then go ahead and glue in the other side, and wipe off any of the excess glue, because all it's doing is adding weight and no strength. The good thing about these spars is that they actually establish the dihedral for you, so you don't have to worry about a dihedral gauge. Go ahead and pinch the tabs on the spars before you lay them down. And for the front spar, the score cuts on the spar will be facing towards the back of the wing. Again, only glue down one side of the spar at a time, so that it'll mentally help you from pressing down on both sides of the wing, which may cause it to crack open and destroy your dihedral, so you have to build the wing all over again, which is not good. Now just open the gate and glue down the other side. It's very simple. Once you've glued in both spars, we can start working on folding over the wing and gluing it down permanently. So start off with the centerpiece and fold it over just like all our regular FliteTest wings. Add glue pretty much anywhere you want. On the leading edge and on the spar should be enough for this piece. Go ahead and fold it over, lay it down, and let it lay down for a good 15 to 20 seconds. And go ahead and remove any of the excess glue that oozes out. Now, this is really important. We're going to come back and actually trim this piece down where it meets the front spar, because that cavity between the front and the back spar is where the wires will pass through the wing, so that's really important. Let's glue in our foldovers. I'm going to start off with the right side. And also, if you want, you can add some glue on the dihedral score cuts to help it establish its shape. This is really optional. It's actually more important to add tape here so that the wing doesn't rip off when you add thrust. So now go ahead and do only one fold over at a time. As I said, if you try to press both halves of the wing down, you will crack it open, which is not good. So add glue on the leading edge, on both of the spars, importantly on the trailing edge, and also where the two wing halves or wing thirds will meet. Go ahead and press it down and hold it for a good 15 to 20 seconds and remove any of the glue that oozes out. And if glue oozes out in these points, it's very good. That means you've covered every square inch of joint that needs to be made, and only the excess glue is coming out, so that's a good thing. Go ahead and repeat the same process on the other side. Make sure that the dihedral is being established well. Now we're going to address the spar joint doublers. We're going to take it and crimp down the outline so that it can be pressed into the wing. And we're going to add one of these doublers next to each spar, just like that. Go ahead and add glue on one side of it and press it in. Now a clue as to where this should fit is that the end of each spar joint doubler should line up with the tab that you see right here on the outside of the spar, just like that. What this is going to do is it's going to add a lot of rigidity to the point where the dihedral on the wing turns into anhedral, because that's structurally a weak point where the wings could fold. But given the presence of the spar and the doublers, I've never had a wing fold ever on one of these B25s. The most important thing is that we have glue, but that's not enough. We need tape on the center of the wing where each section of the wing meets another section. So make sure you add tape on those two joints where the wing thirds meet the centerpiece, because if you don't add that, there's a high chance that your wing can snap off or just tear off like it did on my first prototype. Once that's completed, we can put our attention to the wingtips themselves. So now we're going to start off by removing the servo spacer, the little square on the end, and we're going to save that piece for later because it's going to help us with putting 5-gram servos in the wing. Now also you'll see that you have a bit of a leading edge rectangle on your plans. That's also going to be very important starting off. Go ahead and break open the wing, break open your score cuts, and first of all we're going to remove the paper and the foam from that little rectangle. And what this is going to do is it's going to make the leading edge of the undercambered portion of your wing, the wingtip, it's going to make it a bit more aerodynamic so that the foam board doesn't meet the airflow and rather the edge is nice and rounded. To assist with this, you can actually cut a barbecue skewer to the correct length and fold the paper over that barbecue skewer so that there's a nice rounded leading edge. But you don't have to do that, you can just fold over the paper, and I've done that as well. So go ahead and glue in your barbecue skewer into the leading edge foam. And if you have a laser cut kit by any chance, it'll actually make this process easier. My good friend Aaron Lafon actually made this suggestion to improve the stall characteristics of this of the B25, and I did see a significant improvement on this model after I made this modification. So thanks to Aaron for that. Go ahead and add glue to the bottom side of the wing and use a scrap piece of foam to fold over that paper and establish a nice smooth wingtip. It'll not only fly better, it will also look a little bit better. You can see that I'm using my sander pretty much anywhere where I need to make some modifications. So now we're going to go ahead and remove our tabs and also do our score cuts on the wing and also eventually break open our aileron. Make sure you've removed both servo spacers. When you do the fold over, make sure that the back of the bottom surface of the wing meets the aileron score cut. Go ahead and remove the tabs on the wing and also do your score cuts. Now the score cuts for this wingtip are really important because you can see they get really tight together near the center. So make sure you cut your score cuts deep and widen them out with a barbecue skewer so that the wing folds over nice and clean. Now go ahead and break open the leading edge and do your double bevel as we've been doing. Always use your sander if you want to clean off the bevel. And you should have a good fold over if you do that process correctly. So now we're going to add the wingtips to the center wing. You can see that the spars are already placed, and it's going to make it very convenient for you to add the wingtip. Make sure you're at the edge of a table to assist this process. We're going to go ahead and pinch the tabs on the spars and do a dry fit to make sure that they fit on the outside wings. When you do the fold over as a dry fit, everything should match up perfectly where the dihedral meets the anhedral. So now we're going to add glue on the bottom surface of the spar and the bottom surface of the wing where the two wing halves will meet. When you press this down, you will have a bit of glue oozing out on the bottom, so make sure you go back and clean that off before you glue your wing to the table. would be pretty bad. Go ahead and press the spars down so that they provide a nice strong fit between the center wing and the outer wing. Now if everything lines up well, you can go ahead and do the fold over on the top. Add glue to the spars and to the doublers if you want, and especially it's really important to add glue to the trailing edge of the wing and to the surface where the two wing halves will meet on the top, to that edge right there. If you don't add glue on the back, on the trailing edge, it might be pretty hard to go back and do that. So make sure you do that right away. Remove any of the excess foam and make sure you hold it down for a long time so that it hardens and becomes a clean, strong joint. Repeat the same process on the other side, making sure you add glue wherever necessary and removing glue wherever it's oozing out and adding excess weight. So that brings the assembly of our wing to an end. Go ahead and break open your aileron, and doing the bevel cut is going to be a little bit tricky, so you have to start maybe halfway through and work your way back, and you have to finish off the rest by going in the opposite direction using sort of a hacksaw motion to finish it off. And this is where the sander comes in really helpful, because you can clean off the bevel and make it uniform rather than jagged. So now you have this optional servo spacer that you have to add if you're using 5-gram servos so that you step the servo up. So go ahead and glue it as you see over here. And when you're putting your 5-gram servos in, they will line up with the bottom surface of the wing, making your linkage operate correctly. You also have this wire conduit piece that you can use if you want to make your wiring swappable. So go ahead and do a bevel on opposite sides of this piece, 2 bevels per piece, just like that. And go ahead and place it down. And go ahead and place it down as a ramp so that the wires that are coming through the spars can go through the spar and down to the nacelle just like that. Repeat the same process on the other side. Now we're going to start working on the nacelles. Make sure that you have your power pod built, just as always. Start off with these 2 formers provided on the plans. Pinch the tabs on one of them and then press it into the slots on the other one. Go ahead and add glue on this former from the front all the way to the back. And press in the other former into this one. And make sure that the 2 surfaces meet well. Go ahead and remove any of the extra glue that's oozing out. So now make sure that you have your power pod inserted for the rest of this procedure, because the power pod is going to give a lot of the structural reinforcement when we build the nacelle and start working with this piece. Make sure that the power pod lines up well with the rest of the former. So now we're going to lay out all the rings belonging to our nacelle in the order that they're given on the plans. That's very important. Now you'll see that the 3 rings in the front, including the cowling, are actually flipped around on the plans just to save space. But they should be flipped to face forward, just like this. The middle piece is actually rectangular, so that one you won't have to worry about. Now if you look at the nacelle itself, it cups downward and then it cups upward after that, and in the middle you have a rectangular piece that establishes the center. So we're going to start off with the cowling. We're going to remove the cavity at the end. We're going to remove the paper off of the entire thing. And we're going to slowly start molding it into shape. Now this is a process that you would have done on a Mini Corsair or any of the other builds that involve molding the foam. Go ahead and remove the paper off of all of them, just so that you don't have to worry about that later. Now to establish the curve, go ahead and start off by using your fingers and pressing it into shape. The hardest part is going to be to actually bend the ends into shape, because that's where they'll want to remain straight. So make sure you focus your effort especially towards the ends. If you want, you can roll it off the edge of the table, but if you find that inconvenient or you don't have a table edge like I do right now, you can just use your fingers. Now the key is to make sure that the two ends of your cowling, they meet at the same tangent or the same slope, so that they don't form a cusp or a corner, but rather meet as a continuous surface. Go ahead and add glue on the exposed foam and close together the cowling. You can come back and add glue later to seal down the paper bleed over to close the joint. But you can see that I'm specifically trying to make the two edges meet at the same slope rather than turning them into a corner, because that won't look good, and it's not very scale either. Go ahead and remove any excess glue that oozes out. Now if you're really skilled, you can seal down the paper bleed over along with the rest of the glue that oozes out, but I'm going to go over a second time just to make it easier for myself. Now a lot of this is going to be working the rings so that they look right, because that's mostly the importance of this nacelle, and that's why I designed it this way. It's for the scale appearance. Especially if you paint it, you can make it look really amazing. So a lot of the beta builders really took this design beyond its limits. So thank you beta builders for that. Now when you add the cowling onto the former, when we proceed to add each of the subsequent nacelle rings, make sure that you have the power pod placed inside so that it adds reinforcement, or the formers will crack under the pressure when you're trying to press them in. Go ahead and add glue on the very front part where the cowling will sit down. Making sure that you have your power pod inserted, you can start pressing in the cowling into position. Make sure that the formers press up against the inside walls of the cowling. And scrape off any excess glue if it oozes out, but it really shouldn't. So now we're going to start the long process of adding each nacelle ring to the nacelle. But if you follow directions and you take it slow and steady, there's no reason why you shouldn't end up with a really, really nice looking nacelle at the end of the process. Go ahead and use a table's edge or your fingers to form each nacelle ring into a nice circular piece. Center it up on the bottom and then fold it around. Now a lot of people make the mistake of trying to press this thing into shape, and they form sort of a V shape if you look at it from the front. And it may be tempting to do that, but it won't work out correctly as you work your way back towards the exhaust nozzle. Make sure that the shape becomes a circle rather than anything else. Add glue to the three formers, and only add as much glue as you need to cover the thickness of the nacelle ring that you're adding in. Don't add too much or you'll have to scrape that off, and it's a bit of a hassle. Now you can see that I'm specifically trying to make sure that the nacelle ring meets the formers, but I'm not trying to press it down on the bottom so that it becomes a V shape. So the reason that you have bleed over on the top is because everyone cuts differently and everyone builds differently. So now take off that excess, just trim it off with an X-Acto blade, just like that. And this will make sure that your nacelle sits down well with the bottom of the wing and there's no gap in between. So now you're going to repeat the same process for all of the nacelle rings except for one change. Go ahead and establish the bend on each of the nacelle rings and make sure that you add it in the correct orientation. You'll see that it either angles up or down. Make sure that you choose the right angle, because it's possible to put it on both ways and then it just won't build correctly after that. Make sure that you face it the correct direction. Now the main point with this section of the build is that you need each nacelle former to match up with the previous nacelle former. It's not about building it to look like what I have or trying to make it perfect. It's about building it so that each nacelle ring meets the one before it and has the same shape. Go ahead and add glue on not only the three nacelle formers, but also on the surface where the two nacelle rings will meet so that they take the same shape. And that's really going to be the meal ticket in this process. It's adding glue on the back of each nacelle ring before you put on the next one. Again, add only as much glue as you need to cover the thickness of the ring that you're trying to put on. A lot of people are intimidated by this process, but there's really no need to be. It's not that you're trying to add a new skill to your skill set. It's just you're using the same skill just multiple times over and over again, so that adds to the variability and the probability of error. But as long as you take it slow and you follow directions and you make sure everything is matching at each step, there's no reason why it shouldn't look perfect at the end, or at least very good. So make sure that you go ahead and trim off the excess each time, and make sure that you use the power pod inside to provide reinforcement as you're pressing together the sides to make it glue. Now, if you don't like the result after you trim off the excess, you can always come back with a sander and make sure that you sand down the edge to make it nice and flat so that it meets up against the bottom surface of the wing. Now, this process is going to get redundant, but make sure that you stay attentive the whole time and make sure everything is matching up correctly. The more time and care that you give to this process, the better your nacelles are going to look at the very end. The more FT builds that you have done before and the more handling of foam board that you've had, the more experience, the easier this process is going to be. Make sure that you center up each ring on the bottom former and then start folding it around on both sides rather than starting from one end. It's a lot easier to handle that way. Add glue on each of the 3 formers and on the edge of the previous ring where this ring is going to meet. Now I'm going to go rather quickly through the rest of this process because it's redundant until you get to the back, and it's going to be just the same for each ring. The main points are make sure that you use the right ring as given on the plans, numbered 1 through 8 I think, or 1 through 7, and make sure that you take time in placing it down and place it in the correct orientation, and make sure that each ring matches the one before it. It's sort of a step-by-step process rather than having each ring perfectly match the plans or the 3D model that you have online. Now this is the ring where you could place landing gear if you want. So go ahead and before you place this ring down, fold together your wire for your wheels and place it down. And once you do that, if you want a really scaled look, you can actually cut your nacelle ring in half, glue only 1/2 down, and have the other one just sort of hanging as a flap, like a hinge, as if you have retracts on it. And you can look up real pictures. You can look up pictures of the real deal, the real B25, to see how it works. But I would really suggest you don't go with wheels on this model because it flies much better as a belly lander, and it also looks really, really scale without the wheels on. So I chose not to go with wheels on this. But if you do want to add them, this is where you would add them. The reason I suggested that you watch this video beforehand is that if you do see a step that you want to modify or you want to do in a different sequence, in different order, you can choose to do that rather than starting the build and wishing you had done something beforehand. So at this point, what you would have done is you would have placed some a popsicle stick or something inside the wing so that the wire would press against the popsicle stick when you land rather than tearing through the bottom surface of the wing. So if you're not choosing to do that, good for you. It's a lot easier to fly and build without the wheels, in my opinion. Go ahead and repeat the same process for the rest of these nacelles. I should really add some elevator music to this portion. It's going to get awkwardly silent. Now this last piece is where it gets a little bit tricky because this is probably the tightest curve that you have to negotiate with foam board. But just do the exact same process that you've been doing all along, and just take more time and care to make sure that you pre-bend the foam board so that it takes its own shape rather than having to fight it when you glue it down. The other thing you'll notice is that when you do fold over this last nacelle ring, you'll have a little bit of space before you reach that little tab on the back of the vertical former. It's not that you built it wrong, it's just that you built it your own way, and everybody builds a little bit different in these types of portions. Some people like to cup each ring over the top of the other ring when it has a little bit of paper bleeding over on the edge. Some people just prefer to lay them adjacent to each other. Whatever you choose, just make sure you stay consistent with that method throughout. Other than that, make sure that you go back and sand down the surface a little bit if you have any jaggedy edges that you want to take care of. And go ahead and pinch the tabs on the vertical former, because that's where they'll insert into the bottom of the wing. And the space that you have at the back won't be a problem because you can take care of that later on when we add the exhaust nozzle poster board. So that brings the assembly of our nacelles to an end. Okay, so we're going to start working on the fuselage now. Let's start with the front fuselage piece. You will see 3 lines for the cargo bay, but that's optional. Make sure you do the cuts, but you can leave them for later. We're going to start by removing the 2 strips of paper along the sides right here. Remove the paper even for the cargo bay door as well, and for the other side. You can save the wing punch outs for later. Go ahead and remove the 2 cavities on the fuselage front roof. Now, a lot of people worry about how to mold this fuselage. The easiest way is to use a ruler to distribute pressure evenly over the side wall, rather than using your hand. You can use your fingers to press down on the foam to establish the pre-bend. Some beta builders actually use dowels to actually roll it over like a rolling pin on dough. I just use a ruler and I distribute pressure evenly, and you can actually make it sit down all the way 180 degrees down on the other piece, on the bottom plate. If you do try to use your hand, you can see that the side wall will actually wrinkle behind the airfoil. That's unfortunate, but that's just how it is with foam board. Make sure you establish a tight bend on the bottom, but don't wrinkle the foam itself. Once you're able to have it sit up on its own, then you can start applying the formers and the glue. You may actually need to establish the curves separately for the cargo bay, since it's its own separate flap right now. We're going to start by putting on formers B and C behind and in front of the cargo bay. If you don't have these reference lines on your plans anymore, or you forgot to include them, just locate the back and the front of the flat bottom of the airfoil cutout and just put them there. Right here is the front one, and right there is the back piece. Make sure that they don't glue onto your cargo bay doors themselves, so kick them loose if that's happening. Try to make them as vertical as possible, but know that they will have a little bit of give, so that's fine. We're going to attach formers A and D on the front and the back respectively. Now the area between former A and B is where your battery would go, so you can either just go ahead and add some tape and some Velcro for that battery, or if you want to put landing gear on this plane, this is where you would use the battery tray plate that's given on the plans. So it's around 4.5 inches. You would actually put your own custom landing gear cutout into it so that the landing gear wire pokes down through the front fuselage and into the wheel. And on that battery tray, then you would put your tape and your Velcro so that you can put a battery on top of the battery tray. And what the 2 layers of foam and the Velcro would do is that they would separate the battery from the landing gear wire so that in the case of a hard noseover or landing, the wire won't press into the battery and poke it, because that would be bad. We can start applying glue on the sides of the formers, all 4 of them, but only do one side at a time, one side wall at a time. Don't try to do both at the same time. Again, using a ruler at this point would be really helpful, but if you're confident about the wall not buckling, you can use your hands instead. You can see that the flap for the cargo bay door opened, but that's no problem right now. Repeat the same process for the other side on all 4 formers. You can see that the nice tubular fuselage is being established now. Again, you may need to come back and pre-bend the cargo bay doors if they're flapping on their own. We're going to come back and trim former D so that it lines up flush with the top of the fuselage. That piece on the top was just there to prevent it from buckling when we were gluing the sidewalls together. Next thing we're going to do is glue down the front little flap we have. This is an important piece because this is where the hatch is going to tab in later on and lock onto the fuselage. This is a simple FliteTest style A-fold, B-fold type of matter. One other piece that you have is the optional servo cradle. What this will allow is you will be able to make your servo itself swappable. We'll talk about that later, but if you want a little more reinforcement for your 5-gram servo to sit in, you can just place it right over the cutout on former D, just like that. The last thing we're going to do for the front part of the fuselage is we're going to add the little curvy piece on top. I think I call it the fuselage front roof. Go ahead and remove the cavities on both sides and the paper on the top, and start establishing a nice bend on the piece over the edge of the table or by using your fingers. Then we're going to come back and we're going to do a bevel on both sides of the foam, but make sure you don't cut the paper off on both sides, because that paper is going to help us lock in this piece onto the side walls of the fuselage. It's going to provide a great deal of strength. Your bevels don't need to be really exaggerated like I do here, but if you find that they're not smooth enough, you can come back with a sander and make them nice and even. Once you're happy with the pre-bend, go ahead and drop it down on the fuselage. Make sure that it's angling down towards the nose rather than up. It actually does have a bit of a asymmetrical angle. It's not just a circular bend. Make sure that the piece lines up with the top of former A. Apply glue along these 3 edges and just drop the piece into place. Now, if you're really skilled, you can just, on the same go, you can just seal off the paper on the sides. Make sure that the piece sits down well with former A, and then worry about gluing in the paper bleed over after that, which is what I'm doing on this build. Make sure that you squeegee off any of the excess glue that's sitting there, because all it's going to do is it's going to make your build look a little bit shabby. Whenever you paint or add decals over these things, they're going to really look better, so don't worry about that. So we're going to move on to the rear part of the fuselage. The process is largely going to be the same, except for we're using different formers this time. Go ahead and remove the same 2 strips of paper, but this time you see that the radius of the curve actually decreases. It actually tapers as you go back, so that it establishes the nice tubular fuselage that's so characteristic of the B25. Again, you can try to use your hands on this one to establish the pre-bend, but make sure that you come back with a ruler or you do risk buckling the wall, and I've done that several times. Take your time on this step. Make sure that you bend it over once and then unbend it and then go over and over again, just like we do on the wings, so that you can establish a nice strong bend without hurting the actual foam board. Repeat the same process on the other side. Once you're happy that the fuselage walls are sitting upright on their own, you can start putting on the formers. The main former for the back will be the elevator, but we'll worry about that later on. We're going to start with the former E and do the exact same process we did for formers A through D. First, we're going to glue down the bottom edge onto the bottom plate. And then after that, we can worry about the sides. Apply glue on the 2 side edges of former E and close down the walls. Scrape off any of the excess glue that you have, but make sure that you let this sit for a good 15 to 30 seconds, because the side walls will want to break loose, as you see over here. Next, we're going to come back and add some reinforcement with the fuselage rear roof. Remove the 2 cavities and just glue them down into place. This former will sit right behind former E, sitting up against it. Use a piece of foam board to glue it onto the side walls and squeegee off any of the excess foam that oozes out. So before we go ahead and add the elevator, one other piece that you can add, it's optional, is the fuselage rear cap. I chose to do this in poster board in the beta models, but we realized that it's not, it won't build as easy. So go ahead and use the foam board version of this and remove the 2 cavities and glue it into the rear portion of the fuselage. This is going to be our main former at the back. That's going to help us shape the turtle deck when we glue it on later on. So you can see that the fuselage pieces should be matching up right now since they have the same shaped former. Once you've done that, we can come back and add our elevator. Pinch the 2 tabs on the side walls of the fuselage and glue them in. Do a dry fit onto the horizontal stabilizer. Make sure that you have free motion on your elevators, and if you don't have free motion, you can always come back and loosen them up with a push rod. to reduce binding. Add glue on the horizontal stabilizer rather than the fuselage, and glue it down nice and tight. It's really important to use your line of sight to establish a nice perpendicular joint so that the elevator is not crooked. It's very easy for the elevator to turn out crooked, so be careful for that. Next, we're going to go ahead and add the turtle deck portion on the rear fuselage. Go ahead and work the poster board as much as you can to pre-bend the sides so that you don't have any wrinkling or creasing going on. Make sure that you figure out which way your poster board actually bends easiest. Mine actually bends with the shiny side on the inside rather than the outside. We're going to fold the two tabs that you see over here out of the way. They're actually going to fold underneath the horizontal stabilizer and seal up the turtle deck and make it look like it's actually the same piece as the fuselage, which is really neat. The first thing we're going to do is just put a drop of glue on former E and set down the turtle deck. Make sure you center this piece over the top. Make sure that it lines up at the back. That's the most important thing. Lay your glue down on one side of the fuselage. We're only going to glue down the front part of the turtle deck first, and then we're going to worry about the rest later. Once you're happy with the fit, you can go back and glue down the tab. Make sure that you use a ruler when you do this process rather than using a small piece of foam board so that you can establish a nice continuous fold on the turtle deck. Repeat the same process on the other side. Give it a good 15 to 20 seconds to harden, and then glue the tab down. Go ahead and glue down the rear part of the turtle deck and make sure that it establishes a nice curve over the fuselage rear cap. Again, make sure that you have good travel on your elevators, and if it's binding with the turtle deck, go back with a push rod and cut some relief. So that's good motion right there. In the case that you have some poster board leaking out on the front, which you shouldn't have, go ahead with an X-Acto knife and some sandpaper to trim it down so that it's nice and flush. In the case that you did not add the fuselage rear cap, you can come back with a bit of poster board and actually make your own custom cap. So now we're going to move on to the hatch itself. Make sure you grab the hatch frame and the two formers. Start off by deepening the score cuts on the hatch frame and removing all the cavities, as indicated on the plans. Now, if you're good, you can remove the entire cavity in one go, but if you feel that you're going to have to nibble at it and do it in pieces, you can come back with a piece of sanding paper or a sanding block and remove all the excess. Repeat the same process for all 4 cavities. So all the folds on this piece are going to be B folds, which means the side plate lies beside the bottom plate rather than on top of it. Apply glue where the paper meets the foam, as usual, and using the table as your friend, glue down the side wall so that it sits up 90 degrees with the bottom plate. Remove any of the excess glue that's going to add dead weight to your plane. Repeat the same process for all 4 side walls, or side cheeks, as Josh likes to call them. So we're going to first join together our 2 formers. They're the same piece, they're just doubled up for strength. As they glue together, to make sure that the tabs on them are aligning, just press the tabs and go ahead and do a nice dry fit of the former into the hatch frame. But know that you won't be able to pull it out too easily, so if you want, just go ahead and just jump the gun and lay a bead of glue down on the hatch frame and press the formers in permanently, just like I did over here. Now you should see that the hatch frame actually matches perfectly with the fuselage, lines up back to front. Now this step is going to take a lot of care and attention, so make sure you take the step slow and steady. You're going to have to center the hatch frame on top of the hatch cover poster board. You'll see that I have some reference marks on the hatch cover, but if you lost them while building and cutting out the plans, go ahead and make your own center marks. Start pre-bending the hatch cover just like we did for the rear turtle deck. And the main skill that's going to be used in this step is just eyeballing. If you're able to eyeball the centering of the hatch frame on the poster board, the final result will look a lot better. Apply glue along the top only of the hatch frame and center down the frame on the actual poster board. Fold over the poster board on both side walls and make sure that the bleed over that you have is the same on both sides. And again, I found that as long as I eyeballed it and I felt that it was the same, the final result was a lot better. How you center this piece will actually affect how well your canopy sits down on the fuselage. Apply glue along the side walls one at a time and just use a nice curving motion so that the poster board adheres well to the hatch frame. It's really important to remove any of the excess glue that oozes out because it will get in the way of putting the hatch down on your fuselage. This is a very familiar process if you've built the FT Mini Mustang or a lot of other FT planes like that. So you can see that the windows are actually starting to form together right now. You need to make sure that those two edges meet nice and flush with each other. It's easier to join them with tape than with glue to make sure that you have a nice flat joint rather than a corner or a sharp cusp, which won't look that good. If you're using a thick piece of tape, you may need to cut some relief so that it's able to bend around. But if you use a thin strip of tape, maybe just less than a centimeter, you should be able to just bend it over. Do a couple of passes around to make sure that the joint is nice and solid. The next piece we're going to add is the actual canopy itself. We're going to tape down the tab on the canopy to the back side of the windows. And once we do that, we can see that the canopy is going to start to curve into place and match with the rest of the poster board. You may need to pull on the windows to make the canopy sit down correctly. Once you're happy with the dry fit, come back and add glue on the poster board edge in the whole perimeter of where the canopy is going to sit down. It might be a little bit difficult, but make sure that you take this process slow and carefully. Your hand may come into contact with glue, so make sure your hot glue gun is on a low setting, and also that you just be aware that you're going to feel the heat, and that'll reduce the pain and the shock when you touch it. As you can see over here, I'm removing the excess glue on the inside and the outside. Feel free to reinforce and add glue wherever you need. So the first time you try to put this hatch down on the fuselage, it may be a little bit hard because the poster board will try to cup in and try to prevent it. So adding the hatch in might be a lot of work.
A lot of work. A lot of work. A lot of work.
So now that you have it down, you should see that the paper bleed over on both sides should be the same, and they should match up at the top of the wing punch out. And the window at the front should actually match up well with the fuselage front roof. I reiterate, if you eyeballed it and just made sure that you centered all the pieces, you should see that it sits down well, just like in this picture. So now, the moment of truth when the B25 actually starts to come together. We're going to glue both sides of the fuselage together. Make sure that you apply glue on the back side of former D rather than former E, and also on the side walls of the back of the fuselage. Just like that. Add a generous amount of glue, and if anything oozes out, you can always come back and scrape it off. And as Josh Bixler always says, if the glue actually oozes out, that's an indication that your joint is very strong and solid. Make sure you give this a good 15 to 20 seconds to harden. So now let's talk about securing your hatch on the actual plane. You'll see that there are two holes provided on the side walls of the fuselage. If you pass a barbecue skewer or a push rod through one of the side walls, it should poke through, and it should also go through the formers that are on the hatch, and then it should come out the other side. And that's pretty typical for our FliteTest style builds, and that'll help you hold down the hatch on the front. But if you feel that the backside of the hatch is still flapping up and down when you fly, or even on your test bench, one neat trick that you can do, and I highly recommend that you do this, it's so easy and it's really foolproof, is just go ahead and add a piece of barbecue skewer or a popsicle stick or even a scrap piece of foam board on the bottom surface of the very back of the hatch. Make it protrude out maybe just the thickness of foam board, 0.1875 inches, so less than 1/4 of an inch. If you're able to do that, you'll see that that piece will sit down under former E on the back of the fuselage. And don't make the protrusion too long or you will run into the rear fuselage roof. But as long as you bleed it over only a tiny bit, you'll see that the back of the hatch actually sits down nice and clean. So that brings the construction of our main fuselage to an end. So now we're going to work on what some people think is the hardest part of the build, but really it shouldn't be that hard. We'll start off with the nose tip. Go ahead and remove paper from the 4 side cheeks, or I'm going to call them the 4 flower petals. Remove the 4 cavities you have around the sides. You'll see that the cavities that you have on your plans are a little bit thicker than the ones I have here, and that's how it should be. You may need to cut some relief on the actual cavities to make sure that they come out in one piece, rather than trying to remove the full square ring on its own. Make sure that you scrap out every bit of excess foam that you have clinging onto this joint. Use some sandpaper or an X-Acto knife to finish off the surfaces. Once you're happy with that, we can come back and do bevel cuts on the inside edges and the outside edges of each flower petal. We're going to start off with just the inside edges. Your bevel cuts don't need to be extra generous, but make sure that they're nice and smooth and don't have any, jaggedy extrusions on them. The easiest way to do this is to start off with an actual blade and do your normal bevel cut and then come back with a piece of sandpaper or a sanding block to smoothen out the bevel joint. Do the same process for all 4 petals. You can see I'm using my trusty Dollar Tree sanding block to do the same thing. We're going to come back and do bevels on all the outside edges around the perimeter of this piece. It might seem like you're removing a lot of foam and you just have nothing left, but you'll have to trust me on this. It's going to come out really well at the very end. Make sure that you don't accidentally cut the actual paper on the outside. And if you're worried that you're going to do that, just do an initial cut with your blade and come back with a sanding block like this to finish off the bevel. You won't have much foam left to work with, but that's really a good thing when we start to fold the petals in. Start establishing a nice curve like we've been doing on a lot of the pieces. It's going to be really hard to use a table's edge, so just use your fingers and press in the foam to establish a nice curve. And you'll see that the pieces start kind of coming together like flower petals, just like that. We're not going to fold them all in at once. We're going to do them one at a time. We're going to be laying beads of glue down on the inside edges and the mating edges of the 2 sides that you're working with. You can choose any 2 petals to start with and just work your way around one step at a time. Keep a scrap piece of foam handy when you do this. Try to get the 2 edges to match as closely together as possible, and when you're happy with the fit, use the scrap piece of foam to both remove glue and to seal the 2 paper edges together so that it looks nice and continuous. The more time and care you spend on this piece, the better your plane is going to look. So you can see I'm working around this piece 1 petal at a time now, 1 edge at a time. Add glue both on the inside edges and the mating edges to make sure that you have a strong joint and a nice looking joint as well. Use a scrap piece of foam board all the way through to remove all the excess glue and to make sure that the paper edges are nicely sealed together. So this piece is really small, so make sure that you don't accidentally throw it away along with the rest of your scrap foam. Now we're going to work on the main nose former itself. Start by removing the 3 cavities you can see, and this 4th one over here, which is a bit wonky, just like the one on the nose tip. Deepen the score cuts, break open the edges, break open the side cheeks, and remove your cavities. Again, cutting some relief right here on this last piece will help you remove the cavities. just like that. Now it's not too important to avoid cutting through the paper here because this is a former and everything you do here is going to be completely hidden. So this nose former is going to have A-folds all around, but this time the side cheeks are not necessarily going to sit up at 90 degrees. You're actually going to want to slant them down a little bit. Just do a little bit of dry fitting before you actually put your glue down. And since this is foam board, you're going to have a little bit of wiggle room even after you glue it down, and that's perfectly fine because that's going to help us form it into a nice, perfect former. So you can see how this piece is going to come together, but we're not going to, jump the gun and do all the glue joints at once. We're going to take it one step at a time. So if you've built a lot of FT planes, you know this process. It's just a simple A-fold all around. Remove any of the excess glue that's going to add dead weight to your plane. All the weight that you remove is just going to make this plane fly a lot better. The more weight you take off right now, the more weight you'll be able to carry in your cargo bay and still maintain clean flight performance. So now you see that the very top piece actually sits down nicely on the rest of the side walls. Once you're happy with the fit, just go ahead and glue down the last piece. Apply glue on these three edges and just sit it down. Use a scrap piece of foam board to lay this piece down so that you don't accidentally burn your hand with the hot glue. Go ahead and make sure that this piece sits down for a good 15 to 20 seconds before moving on. So now this piece is also a little bit tricky. You will see that there are some etch lines provided on the plans so that if you want, you can crease them with the back of your knife or with a sharp ruler so that you can establish the pre-creases, which is going to make the build a lot easier. But I'm going to actually do this without the crease lines and show that it's possible to still have a nice, good-looking result. But if you're really worried about your foam board, your poster board not being able to bend around tight radii, around tight curvatures, go ahead and add the crease lines. So we're going to start forming it from the top. Make sure that you put it on with the right orientation. And again, centering it is really important. Make sure that you eyeball it, or at least, if you want, you can use a ruler. Establish those center marks and make sure that you lay this down as perfectly as possible. We're going to start by gluing it on around the back curve and establishing the initial curve on the top. Again, the most important thing you're going to do here is just use your line of sight to make sure that it's nice and centered. Then apply some glue on the front edge and lay it down. So you'll see that this is actually, it's going from an arc to a straight line, but this is not, this is not warping or it's not a compound curve. It's actually just a simple origami transformation. The two arcs actually go to one point, and the point between the two arcs becomes a line. So you have basically one triangle in two conic sections, but that's all unnecessary. Just establish the curve and make sure that it sits down well. Then start laying down the side walls and establishing a nice clean curve. We're going to add glue on the side wall around the perimeter, and also if you want, you can add some in the middle, but that's it's a little bit overkill. Take your time on this step because this is where the nose can really go wrong if you don't lay it down correctly. The easiest way is to make sure that the front and the back sides of the poster board line up with the former, just like you see here. You can see that there's a tiny bit of a crease line that's forming because I didn't pre-crease the foam board. I didn't pre-crease the poster board, but the final result will still look just the same. It'll look just fine. The more flexible poster board you have, the better the result is going to look. Go ahead and lay down the other side as well. Keep your eye out for symmetry all the way along. Now you should see that if you followed the process correctly, the two side pieces at the very end will meet on the bottom plate, just like that. So this nose is designed to be removable, and it's also designed to crumple upon impact to save the rest of your fuselage. So you can always come back and build another nose and just glue it on, no problem. So now you have a little bit of bleed over on both sides. Glue both of those plates down on the bottom plate of the former. Make sure that they line up with each other. Take your time to make sure that the paper doesn't pop out on its own. Give the glue a good 30 seconds to harden. So now make sure that when you add the nose tip onto the rest of the former, put it on in the right direction or else it won't match up correctly. And we're going to add glue around the perimeter of the nose former and also some in the middle, just for strength. So just drop on the nose tip and go around with a scrap piece of foam board and remove any of the excess that you don't need. So you see that our nose piece is now complete. So there are a couple of ways that you can add it onto the fuselage. First of all, make sure that the edges are nicely matching. If you follow the steps, you'll see that the nose matches up perfectly with the front former on the fuselage. If you want to make this nose removable, you can actually press 3 barbecue skewers through the holes that are provided on former A and on the nose former itself. And you'll see that there's a little triangular cutout on both of those pieces to help you actually access the inside of the fuselage through former A. This can be a rather annoying process, but if you want to make your nose removable, you can use this barbecue skewer technique, or if you think that these barbecue skewers are going to be a little bit too weak, which I have to admit they are, you can just use popsicle sticks instead, or another viable option is actually magnets, which a lot of people know and love. So if you really dig this technique, you can try to use it and try to put your nose in this way and have it be removable. But if you find that it's wiggling around a little bit too much, and you don't have access to magnets or any other securing method, just go ahead and glue the nose down. You see that I can actually use the hole provided on the former A to access my battery through the front, so that I can easily position it to establish my CG correctly. So I'm going to go ahead and skip the whole removable deal on this build, as you can see right here. Okay, so now on to what you actually came here for, the scale details. So let's start with the main turret. Go ahead and remove the cavity on the very end and also remove the paper off of the entire thing. This is going to be very similar to the process you did for the cowling. Go ahead and establish the curvature of the piece just using your hands or the edge of a table, and focus your bending motion on the very ends because that's where it's going to be most important. Go ahead and make sure that the two edges meet, and the paper bleed over will be used to seal the joint. Go ahead and add glue at the very edge and seal the two ends together. And if the paper doesn't lock down on the first try, go ahead and add another bead of glue to make sure that it seals down, closing off the joint. So now we're going to add the top poster board piece. Just establish a simple pre-bend on it to make sure you're not fighting it when you glue down, and set it down for a dry fit. You'll notice that it actually curves down and then kind of back up at the very end because of the nature of the former. Go ahead and add some glue on the top edge of the foam board around the former. And to avoid touching the actual glue, just drop the poster board down on the top and then worry about adjusting it. If you're just aware that you're going to come into contact with the glue, it'll actually be a lot less painful if you accidentally touch it. So just make sure that you know what setting your hot glue gun is on. Next, what we're going to do is we're going to make the two holes for the two barbecue skewers to pass through. Just for aesthetic purposes, make sure that the push rod doesn't pass through both sides of the foam, where it might look a little bit ugly when you paint it. To make sure that your barbecue skewers sit down and don't wiggle around too much, make sure that they go all the way back to the back edge of the former, or even through the foam at the back, if you're really precise. And lock them down with a bit of glue so that they don't wiggle around. And that's it for our main turret. So now we're going to work on the actual shells. This is pretty self-explanatory. Just put glue on both sides of this one, this former, and just slide the other one into it. And make sure you do any painting on these beforehand so it's easier. To make sure that it falls a little bit nose down rather than floating around, add nose weight of your choice on the end, but make sure that it doesn't extend the actual shell too much, or the shell may not fit inside the cargo bay after that. So this is the tail turret. We're going to go ahead and remove both the paper and the foam. And it's a little bit tricky, it's a little bit harder than it looks, so take your time on this. If you want, remove just the paper first and then the foam. And you may have to take it in 2 steps. So break off one piece and then work on the rest of it. So we're going to add glue on the bottom edge of both formers and between them to make sure that they seal together. And we're going to do a simple C-fold, making sure that the paper at the bottom is covering the joint between the 2 pieces. We're going to take the rest of the paper and we're going to just round it around the curve to seal off the joint between the 2 pieces and give it a nice curvature. Make sure you scrape off any excess glue and also trim off any of the paper that you don't need on both sides if needed. And that's it. The last thing we're going to do is worry about those 4 nose armament pieces that are given. All you need to do is press a toothpick or a piece of barbecue skewer into the end, and that's about it. If you want, you can add a bead of glue when you press it in so that it doesn't wiggle around or come out in the event of a crash. Again, these are all just aesthetic pieces, so make sure they look right and just eyeball them and it should be fine. So now we're going to attach the 2 wing servos for the aileron. You're going to be running your wires through the wing, but make sure you run them through the trailing edge cavity rather than the leading edge. If you look at it from the top, the wires will pass through and come out right here. And you will need to use your 9-inch servo extensions. And also you can use a push rod with a hook on the end to thread the wires through, and there's a lot of space for you to pass the wires, even with an extension cord. So you will need to cut out little holes for the wings on your servo to pass through. Make sure that the control horn is further away from the aileron rather than close towards it. And also, if you're planning to use 8 to 9 gram servos, which are perfectly okay for this build, make sure that you widen the cavity a little bit more. I'm using 8 gram servos right here for a friend. He gave me these as his personal choice, and this B25 is being built for him. Now, if you're using 5 gram servos, you would have placed the servo spacer in here. So keep that in mind. Go ahead and press in your control horn, do a dry fit, and cut a push rod to length. If you want to make your servo swappable, along with the rest of your power setup, you can actually go ahead and put a Velcro joint underneath the servo, and then to seal the servo in, you can put a piece of tape right here, a piece of tape right there, and then one more piece of tape sealing the servo down. And you can have a little tab on the end such that when you want to remove the servo, you just pull the tab, remove the tape, and remove the servo from the Velcro joint. And to put it back in, it's the same way. So go ahead and glue in your control horn and remove all the excess. So here I'm gluing in my 8 gram servo. Go ahead and repeat the same process on the other side. If you haven't done this already, make sure that your ailerons aren't binding, so go back with a push rod and free up the joints where they meet the trailing edge of the wing. So to pass our wing through our fuselage, we need to make sure that the wires are out of the way. So just pass them through the opposite side of the wing. And so now our wing is all ready for being passed through. To get the fuselage ready for passing the wing through, go ahead and punch out the cross sections for the wing. And now let's work on the elevator servo first. Go ahead and cut a push rod to length and pass it through that cavity that's provided on the plans. Go ahead and attach a Z-bend and a control horn on the other end and pull it as close to the fuselage as possible for convenience to attach the servo. Make sure that your servo arm is swinging this way rather than the opposite way so that it's furthest away from the control horn and it operates without binding against the fuselage. Again, you can either glue in your servo, or you can use the servo cradle provided and use the same Velcro and tape-on-tape technique to seal the servo down, if it's a 5-gram servo. If it's an 8 to 9-gram servo, like right here, you will have to open up that cavity that's provided on the former so that it fits in, just like that. Come back and glue in your control horn for the elevator, and check that you have free motion by wiggling the servo arm. Remove any of the excess glue that comes out when you're pressing this control horn. They'll just make it look ugly, and every bit of weight that you remove will make this plane fly a lot better. So here we have clean motion. So if you're worried that the top portion of the fuselage is going to buckle or wrinkle when you pass the wing through, you can add a barbecue skewer or a popsicle stick or something of that sort to reinforce that thin portion. And this will not only help when passing through the wing, it'll also help protect the fuselage from buckling during crashes. I found this to be a common weak point when this thing lawn darted into the ground. So to pass our wing through, we're just going to do the same rocking motion that we usually do for FliteTest style wings. And at the very end, if you feel that the friction fit is not tight enough, go back and add glue where the wing meets the fuselage, both on the inside and the outside, if you feel that's necessary. So now we're going to add the main turret onto the top of the hatch. Again, this is just based on your personal preference. Wherever you want to place it, it's your choice. Whether you want to place it is your choice. Repeat the same process for the tail turret. And you can look up pictures of actual B25s to see where you want to put these little things. I'm just going to set it down right here, as I've done with all my previous B25 prototypes. Okay, and also if you want to add some barbecue skewers or toothpicks on the tail, that's up to your personal preference. Hold off on adding these things on the nose of the aircraft because you need to make sure that your props have clearance with it before gluing them in. So now we're going to work on adding the nacelles. And this process is pretty simple. Just make sure that you don't add glue where it's unnecessary and where it's going to expose itself. So stop just about right there. Pinch the 2 tabs and press the nacelle in. Make sure you have the power pod inserted beforehand so that you don't warp the nacelle in any way. Just make sure you use your line of sight and just eyeball it. Make sure that the thrust line is pointing in the right direction. That's the most important thing in this process. So now we're going to work on the exhaust nozzle. Go ahead and establish your pre-bend, and don't assume that the shiny side has to be on the outside. Find out which way your specific poster board actually bends better. And actually, when I painted over this thing with a little bit of marker, I think it actually dampened the poster board a little bit and actually made it bend better. So again, this is a very customized, very building dependent portion. So if you need to trim anything into place, like right here, I'm trimming off the vertical former of the nacelle to accommodate this exhaust nozzle. If you need to do that, go ahead and do it. Every build is going to be a little bit different. I've tried to perfect the plans the best I can so that you don't have to do much adjustment. So go ahead and repeat this process on the other side to make sure your exhaust nozzles are sitting flush with the rest of the nacelle and bleed over perfectly on top of the wing. Now we're going to add the cowling roof. I think that's what I call it. Again, make sure you use the correct one for the correct side of the wing. You'll see that one side of it's a little bit thicker, and you can use that to position it correctly around the wing. It's going to pass over the wing and underneath and glue onto the nacelles. So we're going to go ahead and glue one side and then glue the other side down. That's the strategy. So there it is. I've glued in one side. I just need to glue in the other side now. Okay, I'm back again. Now we're going to put our attention to the hourglass piece. This is a very significant piece because it allowed researchers to actually locate some B-25s that were drowned off the coast of California. So it's pretty cool. So make sure you widen up these score cuts, establish a nice crease, and sit this piece down so that it's flush with the both the cowling and the exhaust nozzle. If you need to do any trimming, go ahead and do that at this moment. The glue over here is just, nominal to make sure that it doesn't slide around. It's not of structural importance. This is just a purely aesthetic piece. So just freehand it and eyeball it. As weird as that sounds, eyeballing is the most important because it has to look good. That's the main point of these little pieces. Now we're going to focus our attention on the scoop provided. Go ahead and establish the crease lines that are provided on the plans, or if you don't have them anymore, just put them on yourself with a push rod by scraping the poster board, and establish clean creases on the poster board so that you create a nice triangular shape. Gluing this down is going to be a bit of a hassle, so this is where your advanced foam board gluing techniques will be useful. You'll have to add glue on the very edge of the poster board, which is not very comfortable, but you have to do that. And just sort of set it down where you want it, and go ahead and press down and remove all the excess glue that you don't want. Again, looking at pictures of real B25s will help you determine where you want to put these little pieces. Go ahead and repeat the same process on the other side. Add your cowling roof, and then add the hourglass piece, and then add the scoop at the very end. The reason I suggested that you guys watch this build video or any FliteTest build video before actually building the plane is you can determine when you want to paint these things, because it would be a lot of a hassle to try to actually paint this scoop without affecting the cowling if you want to have contrast in that portion. So that brings our main construction of the B25 to an end. Now is when you want to attach the motors on the power pod if you already haven't. Any 1806 motors would be good for this build on 3-cell and 6-inch props. And once you put on the props to establish clearance with the fuselage, now you can add the 4 nose armament pieces and make sure that they don't affect the prop swing. Since this power pod sits comfortably inside the nacelle formers and it's basically locked in most of its degrees of freedom, you only need 1 barbecue skewer to lock in the power pod, unlike the 2 that we usually use. And you can choose to press it through the cowling, which I have done on all my previous prototypes and the final prototype that you'll see in the maiden video shortly. And it hasn't given me any problems except when I crash. If you're a little bit more afraid and you want to add the barbecue skewer to a piece that's more connected to the airplane than the cowling, you can actually choose one of the nacelle rings that are further back. And that's completely your choice. That's completely fine. Just make sure that you don't run your barbecue skewer through or through your ESC or press the ESC down in that process, because it might affect your electronics. You might have a bundle of wires sitting there. The last bit we're going to focus on is the actual cargo bay, which we're going to cover in a bit, so stick around till then. Probably the most tedious part of this building process is going to be setting up your power setup. The 3 main important things that you're going to have to add in this portion are the 2 ESCs and the Y harness. This B25 was specifically designed so that you have plenty of space in that spar because of that thick wing, and you're going to have a lot of space to pass through your XT30 or whatever other thick wires that you have. Now the Y harness for this build really doesn't need to be that long. You can have it, I think, a good 6 inches on each side would be enough for it to sit down, but to make sure that you have enough to pass through on both sides, I would actually suggest 8 inches on each side. If you have DYS BE 1806 motors, which are a great choice, they're a revolutionary 1806 motor, what you can do is you can actually just pass the motor wires through the nacelle all the way through the spar into the fuselage. If you don't have that and you have normal earthly motors like the MT 1806, or if you want to put 2204 motors or something on here, you will have wires that are going to have to sit up inside the spar. The best way to do that is actually to use a little bit of a string with a little weight on the end. You're going to pass that string through the fuselage into the spar, and because you have that little wire conduit piece inside your wing, the weight on the end of the string will just cause it to pass into the nacelle, and you can use your pliers to fish the string out of the nacelle. So now you're going to have a string connection between the fuselage, through the spar, down into the nacelle, out of the nacelle, and now what you can do is you can tie whatever you want on the end of that weight. Even with an 18 amp ESC, you're going to have to make sure that you package down the ESC wires and the motor wires well, but it is absolutely possible with the APAC that I know of. I haven't had really any problems trying to fit it in. It is a bit of a hassle, but take your time and make sure you don't hurt or force any of the wires in this process. If you have anything extra sitting inside the nacelle, pull as much of it as you can into the spar rather than trying to cram it into the nacelle. If you're really tight on space, especially if you're using a Emax 20 amp ESC, you can take the little cutout that you have on the power pod and you can continue that cut all the way down to the base of the power pod, as you can see in this picture, and finish off the cut. Take off the entire plate. You don't have to work hard, just work smart and plan every step of the way. For example, make sure that you pass the signal wire of the ESC before you pass in the Y harness, because if you try to do it the other way around, you're going to have too much trouble passing the wires through. So take your time on this step, and again, the more experience you have with FliteTest planes, the easier this will be, so that's part of what makes this a more challenging build. We're going to address the construction of the cargo bay. Aside from the 3 servos that you've already used on this model, you need 2 additional servos to operate the linkage, and I would highly suggest that you look at these animations and analyze them well before you proceed to build the mechanism. And I would also suggest that if you bought the APAC from FliteTest, use the 4 servos you got for the 2 aileron servos and the 2 cargo bay servos, and then find another one to operate on the elevator, because you want your 2 cargo bay servos to be symmetrical. To make sure that the doors close properly with a significant margin for operation, to make sure they don't bind or the servo make the servo work too hard, we're going to go ahead and actually cut a bevel on both sides, and we're going to do the bevel on the outside of the door rather than the inside edge. And again, you may have to reinforce and re-bend the cargo bay door to establish its radius. And if the doors actually bind with the side of the fuselage on the belly, just go back and run a push rod through to add some relief. So the control horns that you're given on the plans are a little bit wider than these ones. Just make sure you pick the right pieces out of your kit or your plans. Also construct the wires based on the diagrams that are provided. And again, this is a very loose, customized thing, and since you're probably going to be using linkage stoppers, you don't really have to be exact on these measurements. So go ahead and pass the L bend, if we can call it, through the control horn, and make sure that the 2 sides are symmetrical. There are 2 ways to secure this joint down. You can either just add a glob of glue at the end, or you can do a Z-bend as we always do. But keep in mind that it's foam board and not a 16th inch plywood, so you're going to have to make a little bit of a wider Z-bend. And if the Z-bend's too tight, you can actually lock in the mechanism, which is not too good. So my preference is to just add a bit of glue on the end and use a sort of a circling motion to add a nice glob around the end of the push rod, locking it in. Make sure that the glue doesn't bind with the cargo bay control horn and that you still have free motion on your linkage, just like that. Repeat the same process on the other side. Before you go ahead and pass through the linkage wires, you may need to open up the slots for the linkage if they're too tight. So go ahead and place the control horn so that it aligns, so that the push rod aligns with the slot. The main reason why I made the control horn a little bit wider than you see here is so that you have a little more real estate to glue down the control horn rather than having it glue onto bare foam. Once you glue it down, and also please do look at the reference images and animations provided in this video so that the build experience is a lot cleaner, so that you can actually understand it before you go ahead and add the glue. Once you glue it down, you may want to come back and add some glue to reinforce the joint and scrape off the glue to make sure that the control horn really sits in well. So to make sure that your linkage is working properly, you can actually just wiggle the push rod from the top and make sure that the cargo bay door opens and closes fully. And if it does bind when it closes, come back with a bit of sandpaper to clean out that bevel. Go ahead and repeat the same process on the other side. As before, you can go ahead and operate the push rods from the top of the wing and observe that both cargo bay doors are able to close and open free of any binding. So now you can just drop in your cargo if you want and just go ahead and fly it like this. But if you're worried that the linkage is going to get in the way of the cargo dropping out, or vice versa, you can actually add a wall to separate the two. So in your plans, you'll have another former that looks just like former B and C, except with the bottom cut off, just like that. Place that former as a wall between the linkage and the cargo. Make sure that the cargo is able to still slide in and slide out, and that the linkage is able to operate cleanly. And once you're sure of both of those conditions, go ahead and glue in the wall. Remove all the excess glue. One more time, make sure that the cargo can slide in easily, and also operate the linkage using the push rods from the top of the fuselage. So now we're going to worry about the actual servos. So the first thing you need to do is you need to cut out wings for your servos to pass through. I suggest you watch the remainder of this procedure before proceeding to do anything. So the first thing we're going to talk about is servo horn placement. You want to make sure that the servo horns are close to the top of the servo rather than the bottom, so that you have maximum degree of freedom to operate the cargo bay doors. If you use linkage stoppers, it could be pretty hard to tighten down the screws, but you can, if you're not able to accommodate a screwdriver like this, you could actually come back with a pair of pliers and just slowly tighten the screw one step at a time, and that works fine too. When you move the servo horn up, the cargo bay is going to close, and when you move it down, the cargo bay is going to open. Now, a little bit of engineering. If you're really worried about the weight that the servo has to carry, make sure that the servo horn is pointing directly upwards in the retracted position so that the weight pulls down on the servo rather than torquing the servo arm and burning out your BEC or stripping out your servo. All this being said, for these 5-gram servos, I found that they're extremely tough and you really don't have to worry about anything. My friend actually stuffed a full paratrooper into the cargo bay, and the servos do not strip no matter what aerobatics you do, even if they're not in this vertical position. So it's just a bit of a warning if you're using weaker servos. So as you add in your second servo, one thing to consider is whether you want to use a Y harness to bind these two servos together. If you have linkage stoppers, you can afford to do that, but if you don't have linkage stoppers, it might not be a good idea to use a Y harness, and you would have to trim each servo on its own to have the proper motion. But if you do want to use a Y harness, you will have to place the second servo on the opposite side of the linkage. If you want to use a Y harness, you would have to set it up like this, like I did on this build. Glue down one servo on the opposite side, just like you see over here. Again, on this one, I'm not worrying about the vertical servo horn placement, but if you wanted, that's what you would do, and use your linkage stoppers to adjust that. Trim off the excess push rod if you have any poking out. There are going to be a lot of wires passing through here, and the easiest way to manage them is to make sure that they go over the top of the servo rather than through the middle. It might be tempting, but if you do try to pass it through the middle, it could interfere with the operation of the servo. So I've set this up on a switcher right now, a 2-position switch. And make sure that you really analyze and observe what's happening here before you proceed to build this setup on your own. Because everyone's setup is going to be a little bit different. And the linkage stoppers will provide a great degree of variability for you to customize your build. Another thing that we didn't talk about is if you did place your servo horns vertically, you may have to actually trim off some of that barbecue skewer we added to reinforce the fuselage when we were placing in the wing. So let's talk CG right now. The CG of this plane is going to be right where the front spar meets the bottom of the wing. And I would suggest that you shift your battery such that the plane is either flat or just a touch nose down. If the plane is flat, you're going to get the best of both worlds. You know, a little bit of scale flight, you'll be able to slow down, and you'll be able to do a lot of aerobatics and penetrate. The last thing you can do is you can actually slow down the servos if you have a programmable radio to make it look nice and scale. So you're going to have basic bank and yank control on your right stick. You can choose to add flaperons with a little bit of elevator compensation. It'll really help the glide slope of your plane. And know that you will still have aileron control when the flaperons are down, which is a good thing. I suggest you use differential thrust because it'll help you coordinate your turns a lot better. And here we have our cargo bay slowed down on our Tyrannus QX7. go ahead and load up your cargo bay. Thank you so much for watching and following along. Go make a memory.